Like I said, part of this process is that we can't have radicals in the denominator. We call this process rationalizing the denominator. Usually an answer written in simplest form, like 1 over 6 plus 1 over 3 is equal to 3 over 6 or 1 over 2. In the division of radicals, the denominator of the fraction is a rational number, so it doesn't contain a radical. And the radicand cannot contain a fraction and is expressed in simplest form. So how do I eliminate a radical? Well, we already know from previous lessons that if I had the square root of x times the square root of x, then that would just give me x. Now, because I need to have an equivalent fraction, if I took 1 over 2 and I want to get an equivalent fraction, it means I'd have to multiply the numerator and denominator by the same thing. So say I could multiply this by 3, then I'd have to multiply this by 3. So 1 over 2 is the same as 3 over 6, which we know is true. How does that apply here? Well, here, if I want to cancel out a radical, I need to multiply it by the same radical. But to get an equivalent fraction, if I do it in the denominator, I have to do it in the numerator, which means that this is going to give me the square root of 13 over 13. If I do the same thing for the next example, then how am I going to eliminate that square root of 2 in the denominator? By multiplying by the square root of 2. This is going to give me the square root of 10 over 2. When I get to the next example, I'm not too worried about the negative, but I do need to multiply by the square root of 6. This is going to give me the square root of 12 over negative 6. The square root of 12 can be reduced. So that's going to be the same as 2 root 3 over negative 6. And I can see that there is a common factor I can pull out of here. And that's going to give me root 3 over negative 3. Now, I could have gotten to the same point, and it's not a big issue, but I could have gotten to the same point if I looked at the numerator and denominator and said, well, I can divide both of those by root 2 and simplified it right from the beginning. Dividing the top by root 2, I'm going to get 1. Divide the bottom by root 2, and I'm going to get negative root 3. And it would take me to the exact same place. So if you want to rationalize and simplify, or simplify then rationalize, they both work. Then I'm going to get to the last example. I'm going to multiply the top and the bottom by root 3. And that's going to give me root 60 over root 3. Over 3, not root 3. And the square root of 60 is going to be the same as 2 root 15 over 3. Can't divide it out, so I'm done. Now, if there is a coefficient, the coefficient doesn't really change my process. I'm going to multiply out that radical. When I multiply out that radical, it's going to give me 7 root 7 over 3 bracket 7, because when I multiply root 7 by root 7 to get rid of the radical, I got to put it in brackets. which is going to give me 7 root 7 over 21. And I can divide the top and the bottom by 7, root 7 over 3. So I still need to multiply out the coefficient, but I don't need to multiply the top and the bottom by 3 root 7. I can just do it by root 7. If I did multiply it by 3 root 7 on the top and the bottom, I could still simplify. I would just have to simplify or factor out a 3 from the top and the bottom as well, not just the 7. When I get to the next example, I know this is the same as the square root of 18 over the square root of 5. So I'm going to multiply the top and the bottom by root 5. This is going to give me the square root of 90 over 5. And the square root of 90 I can simplify to 3 root 10 over 5. Now, like we saw with example C on the last case, when I look here, I can see they both have a common factor. 12 and 72 are both divisible by 12, which means that if I divide the top and the bottom by root 12 to begin with, then I'm going to be left with 3 over root 6. And this is a much easier one to simplify. Then I can multiply the top and the bottom by root 6. And that's going to give me 3 root 6 over 6. And if I have 3 over 6, that's the same as 1 over 2, or root 6 over 2. For the last example, where I have the binomial here, it says that it wants us to do it by rationalizing the denominator first, or in the second case, dividing numerator and denominator by root 2. So if I do this by rationalizing the denominator, because it is a binomial, I'm going to put brackets around the numerator and say that I have 3 root 18 minus root 12 all over root 2. I'm going to multiply the top and the bottom by root 2. And that's going to give me 3 root 36 minus root 24 all over 2. 3 root 36, well, that's going to be the same as 3 times 6. And the square root of 24 is the same as 2 root 6 all over 2. Which is 18 minus 2 root 6 over 2. And I can see that I can divide all of these by 2, which is going to give me 9 minus root 6. In the second case, it says it wants us to just divide them out first. So if I'm dividing it out, if I have 3 root 18 minus root 12 over root 2, then I'm going to divide the 3 root 18 by root 2 and the negative root 12 by root 2. That's going to give me 3 root 9 minus root 6. The square root of 9 is 3. And it gives me 9 root 6. And I got to the exact same point. As you can see, if I can simplify first and then rationalize, it takes a lot less steps. All right, go get some practice done.